The first tantalizing evidence of this new force was published in March this year, using data collected by the world's biggest particle collider. Although the news was met with a great deal of fanfare, scientists said they were only cautiously optimistic about the results and their potential repercussions. But new evidence has emerged to give the theory more credence, and that threatens to completely shake up our understanding of the subatomic world. According to the so-called Standard Model of particle physics, the world is governed by four fundamental forces. These are the strong force, the weak force, the electromagnetic force, and the gravitational force. Harry Cliff, a particle physicist at the University of Cambridge, has described the Standard Model as the most successful scientific theory ever written down. But there is a growing body of evidence to suggest the model needs to be updated, if not outright completely rewritten. Discoveries at the 17-mile-long (27 kilometers) LHC, which runs deep under parts of France and Switzerland, suggest there is a fifth force that could explain irregularities in the decay of certain particles. The Standard Model predicts particles known as beauty quarks, bottom quarks, equally decay into electrons, and the heavier muon particles. Dr. Cliff said, beauty quarks are unstable, living on average just for about 1.5 trillionths of a second before decaying into other particles. The way beauty quarks decay can be strongly influenced by the existence of other fundamental particles or forces. When a beauty quark decays, it transforms into a set of lighter particles, such as electrons, through the influence of the weak force. Dr. Cliff said this was an unexpected result, as the muon is virtually a clone of the electron except for being 200 times heavier. According to the expert, all of the known forces should pull on the electrons and muons with equal strength when decaying. Instead, Dr. Cliff and his colleagues have observed the muon decay only occurred about 85% as often as electron decay. The physicist, who discussed the results in an article for The Conversation, said, assuming the result is correct, the only way to explain such an effect would be if some new force of nature that pulls on electrons and muons differently is interfering with how beauty quarks decay. The result caused huge excitement among particle physicists. We've been searching for signs of something beyond the Standard Model for decades, and despite 10 years of work at the LHC, nothing conclusive has been found so far. The discovery of a new force, he added, would be a huge deal and could potentially solve some of the fundamental mysteries of the cosmos like dark matter.